Thank you, Saito-san. And thank you for all coming together today. It's our first hybrid DX Week event. Last year, we had to do all virtual, so it's nice to have both in-person as well as virtual. Today, I will be privileged to interview Professor John Hennessy, who insisted I'm calling him John, so thank you. Before I introduce John, I will be explaining a bit the mission of DX Week, which is all about digital transformation. And today is about computing and connectivity, but it's a full week of sharing insights, which matters for making the planet and society a better place. DX is for digital transformation. We are going to be talking a lot, I hope, and learning a lot from the keynote speech as well as the panel. We do it once a year because we have our code of conduct, our core values, and we call them code of conduct because CODE. C is for contribution to society. O is one team reaching for the sky. D is delivering deep insights, and E is for entrepreneurs first. And we see the entrepreneurs are really the ones who are going to make the changes we need to seek. But we see this event as an opportunity to share deep insights which they can leverage, take advantage to know where to go and where not to go. And that's also why we do a hybrid event, because it's not just for us lucky enough to be in Palo Alto and Bay Area, but everyone around the world to be able to benefit from these insights. Now, without further ado, let me introduce you to Professor John Hennessy, who is the chairman of Alphabet since 2018. Prior to this, he served as a president of Stanford University from 2000 to 2016. He also served as a director of Cisco from 2002 and 2018, held various positions at Stanford, including dean of the Stanford University School of Engineering, and chair of the Stanford University Department of Computer Science from 1994 to 2000. He's also a successful entrepreneur, which is also what makes today very special. And he was one of the founders of MIPS Computer System, Inc. Along with David Patterson, he was a recipient of the 2017 Turing Award for their work in developing the reduced instruction set computer, RISC, architecture, which is now used in 99% of new computer chips. He was also the chairman of Aceros. So you can see the computing and the connectivity, really deep knowledge. And Mark Andreessen called him the godfather of Silicon Valley. I had to finish with this one. So John, I read that when you took over the role of president of Stanford, Walter Hewlett ask you to stop thinking about what's good for Stanford, but what should be good for society, for the humanity. With that, let's start with a very open question, which is, what do you think are the global challenges for humanity today?
Well, we certainly live in a challenging time, and when Walter asked me that question, I started thinking about what the role of universities would be in the world. You know, universities are often, we think of them as these ivory towers, right, where lots of people are talking within the ivory tower, but perhaps not always looking outside beyond the bounds of the campus. And if you're on the Stanford campus, you can understand why people might not want to look outside. But in any event, it was really an interesting question, because I started thinking about universities need to be much more engaged in finding the solutions to the really big societal problems. Because if universities don't engage, where are they going to come from? Where are the kinds of breakthroughs that maybe in an earlier time we got from places like Xerox PARC or Bell Labs or IBM Research, but today those don't exist. And while government's an important implementer, it's not the source of most of the breakthroughs. So today, I think you can see some of the movement that's really important. Obviously, the climate change, sustainable, I have grandchildren now. That problem has gone to the top of my list because I'm thinking about the world they're going to live in. That's obviously a big problem. Figuring out how we continue to improve the quality of life for the people that live in the lower half of the pyramid, mostly in the southern sector of our planet. That's a critical issue as well. Figuring out how we ensure that technology gets used for good. I mean, the AI revolution is exactly that. It's a revolution. After 50 years, 60 years, I mean, we finally got a breakthrough with machine learning of monumental size. Now the question is, how do we ensure that it does good in the world and gets used for lots of good, and we minimize the harms that we have? We've got to think about all these issues, I think, as we go forward.
And doing good in the world for everyone is about equity. I was in a sustainability conference on the East Coast. I won't mention the school, but they talked about the global south. And when we talk about sustainability, we only have one planet. I know Stanford is doing a lot on sustainability and a big focus. Maybe you could double-click on that?
Sure. So we, back when I started as president, we began a planning effort to really try to build up our commitment to working on environmental issues. Climate change was already a problem, but so was sustainability of the rainforests, other kinds of global issues. And we began to put together a university-wide effort really focused around environmental control and sustainable development, and around the energy issues, because the energy issues are so front and center, right? If we can't solve the climate change problem, the rest of the planet is in deep doo-doo anyway. So we began to do that. And I think as things developed and my predecessor, Mark Tessier-Levine, came in, it became clear to us that despite the fact we had roughly doubled the number of faculty and researchers working in the area, we probably needed to double it again to get up to the scale we're going to need for this problem. It's a really hard problem. In fact, there was a great, I was talking to Bill Gates, and he had a really great insight about this. He says there are two groups of people that get the climate change challenge wrong. Those that think it isn't going to happen, that climate change is false, and those that think it's going to be easy to solve. And I think that second insight is the one that's really, this is going to be a really hard, possibly the hardest problem we've faced after perhaps dealing with the threat of nuclear weapons. But it's on that scale, I think, and it's going to require global collaboration. So the decision was made that we needed to create a whole new school focused on this problem, because the scale that we would have in terms of the number of faculty devoted to the area was too large to just have a kind of loosely knit configuration that bring together various schools. So that was the idea, and thankfully John Doerr, a good friend and longtime investor in a number of Stanford spin-outs, was willing to step forward and help us make it happen, and that was really terrific to see.
Thank you. And for the entrepreneurs who are listening, why is sustainability so hard, and how can technology help?
Well, we do need technology, and I think this is a problem that's going to require us both to invest deeply in technology. I believe that in the long term, technology will be the cornerstone of the solution, but we're not going to get there fast enough because the breakthroughs we need. I mean, look at battery progress. And I don't want you to just look at the price of batteries, because, of course, Elon's success with electrifying vehicles has driven the price down pretty fast. But energy density goes up between 5, 6, 7% a year. Not very much. And we need to figure out, we need a breakthrough. If I had a silver wand right now, I'd wave it, and we'd have a bulk, low-cost energy storage capability. Because if I had that technology, then I can dramatically accelerate the renewable energy solution, because I have a place to store that energy at night. I was giving a talk a couple of months ago, and I asked the audience, it was down at the Computer History Museum, so you can guess there are a lot of techies. I said, well, how many people have an electric vehicle? Now, how many people have an electric vehicle? Okay. How many people plug it in at night? And that sun is shining for you. It's just not shining locally in California at night. So there's a small problem there that we've got to solve this problem. You've got to have energy storage. So I think there's a good example of a technology. Fusion, You know, it's the technology 20 years from now, and it always has been. But if somebody makes the fusion breakthrough, and I think there are some big investments in some interesting new approaches that could lay the groundwork, but together with those technology innovations, we're going to have policy change. And my silver wand over policy change is carbon tax. Carbon tax. And it's not such a horrible thing. If you look at, I think within 5 years, we can get CO2 sequestration down to a cost where the added cost of a gallon of gas might be $1. To be carbon neutral, you'd have a carbon neutral source. $1 a gallon, it was more than $1 a gallon a year ago. So it's an affordable, I'm not running on that as political, because I know where that would go. But you know, we're getting there. So technology together with policy is what's going to get us to this solution before we destroy the planet.
Although it sounds like it's also about unit economics to get to the right place.
It's absolutely. Because in the end, Tom Friedman once said, you've got to find a technology that solves the problem for a price that China is willing to pay. And as the largest, China's the largest consumer and burner of coal in the world. Coal is 4 times worse than natural gas. So we've got to get rid of coal. We should just outlaw coal globally, right? But obviously, while the United States has made a lot of progress in eliminating coal, it's been much harder in other parts of the world.
So I promise I will ask computing and connectivity questions, but that's an important topic. And we invested in nuclear fusion at TDK Ventures.
Yeah.
Type 1 energy, so we do hope it's no longer 20, but more 10 years.
I think the question is, when is it a research topic and when is it a company? That's the key question.
Actually, the way we looked at it is, when does it become no longer science risk, but engineering risks?
Yeah. Well, it's always been engineering. We understand how fusion works scientifically, so it's always been engineering risk. You just have to be able to get something to 50 million degrees centigrade and hold it together in one place.
Not easy.
No, not easy. Not easy at all.
I just wanted to double click on the carbon tax because there is an element of equity. You mentioned the global south. They are behind on sustainability, and to have a carbon tax that would be the same for everyone would not work.
Yeah, so George Shultz, when he was still alive, bless his heart, tried to get the Republican Party to sign on to doing something about climate change. He campaigned hard on it. He didn't have that much success, but he had a very interesting proposal. He said, there's a carbon tax, and then there's a yearly rebate at the end. And the rebate is per capita. So if you are a low carbon generator, you'll make money on the deal. And the person who's throwing a lot of CO2 out will pay money on it. So you could think about extending this globally, for example, so that we would ship money to countries which were low carbon generators.
Yep. Let's move to computing a little bit. It would be strange not to talk about ChatGPT. Clearly in November, something very meaningful and transformative happened. People realized that AI can be as smart or sounding as smart or looking as smart as us and doing a lot of things we never thought could be happening. How do you think that type of AI is going to help us and help entrepreneurs bring positive value to society?
Yeah, so I think clearly, you know, there have been a series of breakthroughs in the last decade, roughly. The CNN breakthrough, for which Hinton and his colleagues won the Turing Award on image recognition, AlphaGo, AlphaFold. Here's an AI application, has nothing to do with language or anything else, right? Imagine, and you know, my colleague at Stanford won the Nobel Prize some number of years ago for work he had done on protein folding. And I asked him about this. He said they advanced the state of the art by 20 years, this one technology. So and obviously the generative AI momentum is here. I'm starting to use it to compose emails and letters of reference, you know, and it gets a good first draft. But yeah, you have to, prompt engineering is very important in this world, so you have to give it the right prompts. But I think there's a lot of potential here to improve productivity and really make it useful. And obviously, we still have a lot of work to do. I mean, training it on the entire internet is probably not the wisest thing because there's a lot of garbage as well as useful things. We've got to be more careful about what we train it on. Training it on Wikipedia is pretty good because Wikipedia is pretty accurate. I mean, 99%, 95%, somewhere in that range. So it's pretty good. We need better training data. And we're also fiddling around models. Can you make a smaller model and maybe train it better? And maybe then the results will actually be better than a big model that's trained with a lot of data, which is not carefully curated.
Actually, I'm glad you mentioned Wikipedia is accurate because we use your bio from Wikipedia.
Yeah.
But how do you see the training on smaller set? Is it not a risk of bias being even stronger than a bigger set?
Yeah, so there are clearly bias issues, and I distinguish between, there are two kinds of bias, at least two, maybe even three. There's bias that comes from the data, which is built-in societal bias, right? So if you were to train something to look at income, right, and somehow related to race or ethnicity somehow, you'd pick up the bias that exists in the US data. So you've got to be alert to that. You've got to be aware of it and think about how to use it. There's also bias in the algorithm where one of my colleagues, Emma Brunskill, has done this, where she demonstrated in some cases the algorithm actually accentuates bias that may exist in the underlying data. So it overpredicts some kind of situation that it otherwise wouldn't get right just from the data. So we've got to figure out how to do a better job on bias. Now, remember that if the AI system is replacing a person making decisions, guess what? People are biased also. And you know what else? You don't even know what their biases are. At least if I have an AI system, I can begin to I can test for bias. Can you imagine telling people when they come into a jury, let's say, oh, we're going to give you a bias test now to see whether or not you have certain biases that may lead to a higher probability of conviction. I mean, so I think we can do a good job here. Somehow we have this image of people being perfect. I haven't met somebody who's perfect yet.
And do you see a hope for this bias detection to be used for assisting humans so that actually we are more aware of our bias?
Sure, I think we can certainly do that. We already have psychological tests that will reveal biases that you may have, that you're unconscious bias. So I think we can begin to do that. I think there are obviously lots of areas where we want AI to be an advisor to the human who in the end makes the decision. I don't, when I have an AI system that's doing diagnostic work and it's about to tell me I have some terrible disease that I'm not going to live very long, I really do want a person to tell me that news and share it with me in a personal setting. But I probably do want the AI system to look at all the data and really try to come up with that insight into the diagnosis. That is fairly hard for physicians now. I mean, if you look at the job of a physician now, diagnosing something that's a little more rare, right, with all the tools that are at her disposal, and how did she do that, and how did she reach the right diagnosis as quickly as possible? That's a really hard problem. But I can deploy some Bayesian reasoning, some machine learning, and really make an advance on it, I think.
And all this advance of generative AI, which has really a lot of good applications, requires new type of computing, new type of connectivity. What are you most looking forward or excited about the next level of computing for this?
Yeah, so we've kind of, if you look at what happened with processors, we've kind of reached the point of diminishing returns in conventional general purpose processors. And by conventional general purpose processor, I mean a machine that can run a hunk of C code that is just sitting there native and doesn't have a lot of hints on how to do it efficiently or something, right? So it's got random pointers, it's got all the things that we're used to programming and that good programmers can do to get efficiency up. But we've kind of reached the end of the plateau, and if you think about it, it's really an energy efficiency. It's silicon efficiency to some extent, but energy efficiency is the big issue. And the reason is the techniques we use. Think about speculation, right? So all these machines speculate now, and I mean, if you look at a recent Intel processor, you know, it's got 100, maybe 150 instructions in flight at any given time. So it's speculated through 3, 4, 5, 6 branches, right? And what are the odds that it got each one of those 6 branches right? Because unless it got each one of them right, we're wasting time and energy. So speculation is kind of played out. It probably can't go a lot further. Even caches can't go a lot further. I mean, you build a multi-level cache, and you know, we were up to 4-level caches. I mean, it doesn't make any sense to go anymore at that point. So we're kind of playing that out. The interesting thing is, you might say, if you put aside the AI revolution, computers have gotten a lot faster, and it's a little harder to find novel applications that really could be paid for or could justify much faster computers. But then you put AI into the mix, and all of a sudden, for training and for inference and complicated things, we've got computationally demanding things. They behave very differently than traditional applications. They do a lot more streaming data access. They do a lot of linear algebra, both sparse and dense. So the machines need to be built very differently, and we need to move into this era of domain-specific computers, where we design a computer to do a class of problems, not one application, right? We know how to design a computer for one application, right? There's lots of them inside your cell phone. They do one thing, right? But we need to design computers which can do a domain of things like train or like inference kinds of problems, and make them very efficient. And we do that by using a variety of different techniques, right? You don't need 32 bits for a lot of things. You don't need 64 bits. IEEE is way overkill for most of these kinds of problems, right? But you've got a lot of parallelism, and you have to exploit that efficiently. And you've got a lot of streaming data accesses, so caches may not be the smartest thing anymore. But the programmers know a lot more. And so by combining both new programming systems, things like TensorFlow or CUDA, that are designed to program in that environment, together with new architectures. I mean, the levels of performance. It's interesting now when you think about the fastest machines in the world are now being used to train these large language models, not to do these giant scientific calculations anymore. They have some big machines, but the fastest machines in the world are now being used to train large language models.
And when we see the announcement between Microsoft and Oracle, we can see we don't even have enough machines.
No, we don't. There's a giant shortage right now. Because, you know, we were talking at Alphabet how long it takes to train new models. And the unit we use is exaflops months. So how many months with how many exaflops of computation? An exaflop, by the way, is 10 to the 18th floating point operations per second. So that times months is the training time for these large language models.
You talked about good programmers. It doesn't feel like we will need good programmers anymore.
Yeah, so I think don't trust the code you get out of a large language model. Dan Bonet, my colleague at Stanford, has written this paper that basically says, well, the problem with large language models as code generators is they don't always get it right. But we believe they got it right, and they believe they got it right. So basically, the code's wrong. Nobody looks carefully at it, because everybody knows that reading somebody else's code is really hard anyway. So kinds of things slip through. And one of the things that Dan documented in this paper is that with respect to security holes, that's where it's possibly most dangerous, and where we basically need a programmer. Now, that doesn't mean simple kinds of things like a UI for something that's going to be easy kind of stuff. I think you will get decent code for those kinds of things.
I already can see a joke where a programmer will say, oh, we have a security problem with AI, and then someone will say, oh, just call another AI to fix it.
Yeah.
So let's talk about one of the golden nuggets you shared earlier about different class. and clearly you have inference and training. On the training side, how do you see the different classes that would need different type of computing?
Well, there's a scale issue. There's the size of the training set. You're also, if you want to train these machines, if you want to train these new models faster, you're going to have to train on multiple clusters. So you're going to have to distribute it, which means you're going to have to change the training algorithm slightly because you can't modify the weights globally instantly. So you've got to think a little differently about how you do training, and this is one that probably there's only a few handfuls of people that have actually had to wrestle with this problem yet, because it's only people that have the largest language models. But it's going to continue, and I think we'll figure that out, and we'll make progress on how we do it. You look at the progress we've already made in terms of building processors which do these training problems efficiently.
And I want to double click on the curated data. Does that create an unfair advantage for companies that have this big bespoke data versus entrepreneurs who start with no data?
Well, there's lots of public data. I mean, as you can see from some of these models, so people have trained on these things. There are a bunch of issues that we haven't even begun to figure out. What does copyright mean if I train my model partially on somebody's data that's copyrighted? What does that mean? How do I know when I might actually owe somebody something to pay for the use of their copyright? Because there's no clear linkage between the data that it was trained on and when it gets used in an inference problem. So we've got a whole bunch of societal issues we're going to have to figure out there. Clearly, availability of data is going to be crucial, but the key is going to be the quality of the data as much as the quantity. And so far we've emphasized quantity, but we're going to have to put a lot more focus on quality.
I ask you about what you're excited about computing. How about connectivity?
So I think we've seen lots of progress in connectivity, and I think we're pushing the edge of optical, for example, getting a lot closer. I think things which 10 years ago we never would have thought of converting to optical to connect, today we would, and inter-rack kinds of things, very short haul things are now going to go to optical to get the bandwidth up, and we'll pay the cost of electro to optical conversion. That's an area where if we had a real technology breakthrough that did some kind of hybrid solution, so that we didn't have to cross a package boundary to go from electrical to optical, we could really get significant enhancements in terms of performance per power. I think, clearly we've become this wireless world, and it's completely happened, and I think we'll see continued progress there, although there are certainly challenges in making further progress on that. In terms of distance issues and coverage and all kinds of things like that, that we're going to wrestle with. But I wouldn't, just as the Wi-Fi generation was a real breakthrough in making that technology work in CMOS at reasonable power levels, I wouldn't put it past another breakthrough coming through and somebody really making a big jump in terms of mobile connectivity.
I think we have Paul talking later who can speak to that.
For sure.
So before I take questions from the audience, both in person and online, I'll ask a fun question. If it's not 2023, when do you think singularity is happening?
So I think, so there's two parts to this question, or two parts of the answer. One is, when will large language models pass the Turing test? I think the answer is they pass the Turing test today for people who aren't experts. They pass the Turing test today. There's no way somebody who's a basic computer user couldn't be equally fooled by a large language model. So I think we're already at that level. The singularity problem applies that it's some sort of artificial general intelligence kind of level. Okay, so here's what I'd say. I used to think 20 to 40 years. I cut that in half. But some of my colleagues would say within 5 years that we'll get there. But I think within 10, we'll get there where even an expert across multiple disciplines couldn't tell whether they were dealing with a computer or a person. Now, this isn't how the computer doesn't start replicating itself and unplugging humans and replacing them. But I think in terms of capability, multimodal, across different things, I think we'll be there.
And actually, if it's domain specific, it's probably 1 to 2 years away.
Yeah, domain specific, where there, I mean, even mathematics or code. I mean, mathematics, I think these new systems, Bard can explain mathematics to the level of somebody who's a graduate level researcher in mathematics. And that's pretty good, since that's probably the 98th percentile of human cognition in terms of math.
When we talk about innovation, and that's my last question, so if you want to ask a question, please raise your hand. If we think about innovation, it's typically by looking at 2 breakthroughs from very different domains and putting them together. Do you see an opportunity for AI to be even better at it than humans?
Well, I think what we're going to see, one of the things we're going to see is, if you think of AI as programming by learning from data, think of it that way, right? Instead of programming the way we've normally programmed, you basically take a gigantic database of observations and you train a system to do that. I think this is going to be a much better way to program lots of applications in particular. So one I love is, think about a large cloud server that, you know, Microsoft or Amazon or Google is running somewhere. Think how hard it is to optimize the behavior on that cloud. You've got lots of different applications with different usage patterns, and they're running, and then different numbers of virtual machines and all kinds of things, and different amounts of memory and I/O and all this kind of thing. And for many years, what did we do as systems people? Well, we designed a bunch of heuristics to try to optimize that. It's way too hard to optimize with a bunch of heuristics and know that you have good behavior. But suppose I have an AI system that observes the system, observes the behavior of different kinds of applications, and now learns how to optimize that. So this is kind of AI as an optimization tool. I think we're going to see more and more of that sort of thing.
Thank you. Who wants to ask? Jeff. Do we have a runner? Yes. And he's running. Nice.
It wasn't a secret that Google, had built some of these large language models several years ago. It just took a while. My question is, what's next? We deal well with images. Now we're dealing with natural language processing and language and voice. Where do you think the next big bang is going to be? I have my own opinions, but I'm kind of curious. Like, the seeds must have already been planted now. Like, the AI frameworks continue to evolve, and we've now got a few good ones. What do you think is the next big breakthrough?
That's a good question. I think my guess is multimodal models are going to, GPT-4 is the kind of first cut at a multimodal model. So I mean a model that will do natural language, but also have in-depth domain information. So it can discuss, for example, a mathematical proof. Not just show you the proof that it got from somewhere trained, but actually explain the proof in natural language. Explain a piece of code. So one of the things that the guys at DeepMind are trying to do is not only write code, but you can then ask, why did you write this piece of code this way, and get an explanation of it. I think video, we've already seen some deep fakes that are really worrisome. Right? Not full video, well, almost full video. Let's say a head-on zoom with lips moving, the voice matches the voice of somebody, but it's not that person. That's already happened, and they're trying to use it to do terrible things in the world. So we've got some issues there. One that's going to be really important is one that one of our scholars at Stanford worked on. It's called Detect GPT. So I think we're going to have tools that detect whether or not something is a deep fake or not, and really deal with that. You know, it's a little hard to predict because these systems the large language models have emergent behavior. Not emergent in that they're starting to come alive in some way, but emergent behavior in that they do things that the people who built them wouldn't have guessed ahead of time. They're more capable than the people would have guessed. And I've never seen that in computer science. Never in my 50 plus years and 60 plus years in the field.
We saw a glimpse of this with Go, where some of the world champions were surprised by some moves.
Yeah. I mean, it's AlphaGo. It starts out, it makes this move that no Go champion in the world would ever make. And so as he said, Sudoku said it, and he said, it played a creative game. Well, when you talk about computers being creative, that's a kind of different thing.
Creative and elegant.
And elegant, yeah.
Okay, another question? Pete?
Hi, I'm Pete Moran. I'm just an angel investor these days. I really appreciate your comments on AI. I wonder if you could go into self-driving in particular. You know, Waymo and others have wildly good cars, but it seems both the public and the regulatory regime expect essentially 100% or very close to that, where my understanding is, you know, we may be at 99, but it's a long way from 99 to 100. Are we going to get there, or what do you see there?
Yeah, you ask a very good question, and your assessment of the situation is 100% correct. The problem for several years has been misbehaving human drivers. And what happens, including one case, for example, that happened with Waymo, where a human drove through a stoplight at 60 miles an hour. Now, you tell me, if you were driving the car in the other direction, how you were going to avoid the accident. It wasn't going to happen. You know, most of the accidents that the Waymo vehicles have been rear-ended. And guess what the person had in their hand in more than half the cases where they were rear-ended. So we have that problem. And this comes down to, it is a regulatory issue. You can outdrive 90% of the drivers, and you can outdrive all drivers who are as old as I am, all drivers who've had even one drink, and all drivers under 25. You can outdrive them by an enormous amount. So I think if we would just deal with the regulatory issue and figure out how to scope that appropriately, and figure out how to make these vehicles, we're going to have to drive the cost down, because you really do need additional devices on this that make it a little more expensive than you otherwise would. But if we could get some new technologies, that cost could come down as well. So I think that would help bring the cost down, which would make the cars take off better. But we're going to have to deal with what the state thinks about what's an acceptable driving. If you look at what people have to do to pass a driver's test, there's no way my autonomous vehicle, it can easily pass that driver's test. Easily. It can pass it, you know, on the darkest night in the worst weather. And we'll have to do other things too. I mean, so for example, you have a problem, what happens in bad weather? Well, what do human drivers do in bad weather? Well, the smart ones slow down. They slow down, and the stupid ones get in accidents. So we have to do the same thing in these vehicles. Just slow down when there's very heavy rain or heavy snow, and you can't navigate as well. So that's what we have to do.
So I'll give a plug. On Wednesday, we have our DX Week on mobility, and we have the SVP of Nissan who's going to actually talk about this. Okay, one more question, maybe. Do we have any questions from the online participants, Andrew? No? Okay.
Hi, Dr. Hennessy. Thank you so much for this great sharing with us. Learned a lot. So I am Nan. I'm with Qualcomm Ventures. I want to bring the question back to generative AI, and I echo a lot with what you said, the value of the data, and also Jeff asked the question on the next Big Bang. You mentioned about the domain large language model. So does that mean that the data, the value of the data, especially the private data in any specific vertical or domain sector will be, I guess, super important and become the technology moat for any startup who want to build and become the super, I guess, next ChatGPT for that domain specific?
Sure. I think domain-specific data is very important. And in places where that data is not publicly available, then the data has a lot of value. And the people who assembled it and own the data should get to take advantage of that and figure out how to use that data. And I think that that's going to be critical. I mean, if you look at some of the progress on things like medical diagnosis, it's been possible because there is data out there that we use to train physicians, right? So you want to train somebody on reading x-rays. Well, how do people who are radiologists get trained? They look at lots of x-rays. So those x-rays are out there and you can do that. But there are lots of domains where that data is not publicly available, but where it has tremendous value, and we'll have to figure out how to leverage it and compensate the people for it.
Maybe I'll double click on this. When it's domain specific and driven by data collected by sensors, is there an opportunity or risk that this data is sensor specific and therefore limited to certain applications?
Yeah, I think there is some risk, or the data is not as complete. You don't have everything you need, right? Or you might argue if it's sensor data, it's being taken from public square somehow, and then who owns that data and what does it mean? Obviously, we're going to have a lot more issues of figuring out what ownership means and who owns the data that we're going to have to wrestle with. And it's going to be a combination of regulatory issues and company decisions on how that's going to happen.
If the regulators are listening to us, what would be your guidance on who owns and who has copyrights? And is there any guidance you would give to regulators? Because that seems urgent to think about it.
Yeah, I think it is urgent to think about it. I think regulators need to think about who actually owns the data and has some stake in it. They need to think about flexibility in their rules. The worst thing they can do is codify something that can't evolve over time. We have a law that was codified many years ago and can't evolve, and it's called copyright. And it still treats information as if it were a physical book and there's a single copy of it in a single location, right? Which obviously doesn't make any sense in the world we live in. So we've got to have rules that are flexible. We've got to have people who are doing regulatory work really understand technology. Yeah, we need lawyers, but we need people who also understand the technology as well, working together with the regulatory people.
It sounds like you're volunteering.
Been there, done that.
More questions? Yes, on the right side. Oh, sorry, first here.
My name is Sanjeet. I'm from UFOS Capital. I wanted to focus on video. There is a growth of video happening, and you talked about multimodality of GPT-4. I want to put the hypothesis that that's not enough. It's pretty insufficient. And I feel that there needs to be new models focused purely on video. And as growth of video happens, text will always be there, but not be the most significant form of data. What is your thought process around creating need for creation of a video-based model, not just have LLM add this as a modality?
Yeah, I think you're absolutely right that video is complex enough and has enough of its own characteristics that a separate model for video is probably advantageous both in terms of the quality, but also in terms of the scale of the model and the complexity of the model. I think the multimodal things will do basic kinds of video fairly well, but doing more generative video that looks realistic is going to be a much harder problem. And for those kinds of things, you probably do want a model that's specific for that particular application. And I think that'll evolve over time, I think.
Thank you.
Okay, now we have our runner running all the way to the other side.
Hi, Eric Hostler, Xlite. I'm a semiconductor manufacturer, so I just wanted to kind of get your read on, as you were saying, we're coming up against some limits with general compute. How do you see advances in semiconductor manufacturing, particularly photolithography, for this next generation compute?
Well, if you can get a breakthrough in photolithography, all the people that use semiconductors, because of course it's been the driving influence. I mean, we all look at the progress in computing, but we have to champion the people who've made the progress in integrated circuits technology that have enabled this progress in computing. And if you look at it, think about how we program now. We write code in Python. Right? Python's about somewhere between 50 and 100 times less efficient than writing code in C, right? In terms of how fast efficiency run. But of course, it codes much faster. So we've made this trade-off. That trade-off wouldn't make any sense except for the fact that the integrated circuit industry has enabled computing to get so cheap that we can do it. If we make I would love nothing better than for somebody to stand up and say, I'm going to extend Moore's Law for another 50 years. I think that's going to be very hard to do, but stretching it as long as possible, and to the extent that one can think about technologies that would get that back to some approximation to Dennard scaling as it used to be, would be monumental, because I never thought I'd live to an age where processors would slow their clock down or turn off cores because they were going to burn up otherwise. But that's exactly what they do. I mean, it's amazing that we've had to do that, and that we figured out how to engineer it so that it actually works. But getting some progress, and clearly lithography is a big part of that. I mean, and whether or not there's something beyond deep UV that we can get to that really works, and that is cost effective. You can do direct E-beam, but nobody's figured out how to make it cheap. And electrons are nasty compared to photons to deal with. So there are a bunch of issues like that. The longer we can extend that, the better off we are, because I don't think we yet have a good replacement for semiconductors that will give us a general purpose kind of computer. Quantum, maybe, but I can imagine when my phone uses a quantum computer, I'll have a set of radiators sticking out my back to get rid of all the heat and keep the thing at the temperature it needs to run as a quantum device. So we've got a lot of issues we're going to have to work out. But I've had the incredible privilege of living in the golden age of computers and integrated circuits, and it's going to be more challenging for the young people in the audience.
I think quantum computer in the pocket is further away.
Yeah. Quantum computers, yeah. And they're not general purpose computers. They're specialized computers for certain kinds of problems. They're the best computers I know for simulating a quantum system, though.
Exactly. There's one thing you said, which I'm a software background, and you just said something really profound for me, which is most of the programming language have been made to make it easier for humans and for certain applications, but with now AI capable to program really, really well, and increasingly well, is that not the time for return to C or even assembler code, where actually you could get 2 orders of magnitude improvement just because of that?
Yeah, it may be, it's interesting because it reminds me of a question I asked Maurice Wilkes. Maurice Wilkes was the last living first-generation pioneer of the computer industry. He died a few years ago at 99. But by last living, I mean, he knew Eckert and Mauchly, saw the ENIAC. He built the first stored program machine, a machine called EDSAC at Cambridge. And I once asked him, I said, Maurice, you've seen all this technology over time. What's going to happen if the hardware doesn't keep speeding up the way it's been going faster and faster every year? He goes, the programmers are going to have to get a lot more careful about the quality of their code. And that's what's going to have to happen. Either that, or we're going to have to build more sophisticated compiler systems that can do this. The problem is it's one thing to do it for something written in TensorFlow. It's a completely different problem to do it for something written in C. So we're going to have to figure out some way to navigate that through, and it'll generate some interesting new research, I have no doubt.
Thank you. Yes, G?
Hi, Gayatri or G with Hitachi Ventures. I just looked up on Bard, and it said it takes about, or GPT model emits about the same amount of carbon dioxide as it does as a car that drives for 100,000 miles, right? So you talked about reaching singularity in like 10 years or so. What is your view on sustainable AI, and can we get there without burning the planet we live on?
Yeah, so first of all, you have to separate out training from inference. You're not going to train these models every day. You're just not going to do it. And that has some implications for how we merge large language models with things like search so that you can get up-to-date information, because you're not going to be able to train the model every day. You can do some fine-tuning to add more recent news events, for example, in there, but we're going to have to find a better way to kind of merge these technologies. I think we're going to more attention to how we're going to, what hardware we're going to use to train these things, train them more efficiently, get green sources for energy so that they're not generating CO2 when they're being trained. And then inference, I think, is not. Inference is a much easier problem, much smaller quantization. You can use smaller, very small. I mean, it's amazing the things people have done with inference using only single bits for weights. I mean, so there's a lot to be done there that will be really important, and that will have to be important because the edge devices are not going to have large power supplies. They may even be on battery, but they're where you have to do inference, right? So we're going to have to figure out how to merge these things along and find effective ways to solve the problems.
I want to explore a bit more the edge devices. It's actually the interconnect between the computing and the connectivity. Yeah. Where do you see the biggest opportunity for edge devices to be really useful?
Well, I think, there's some notion of something that I carry around that's the ultimate personal assistant, right? Which we don't quite have yet. You have bits of it on your phone. You had a little bit of things like Google Glass and things, but we didn't really get it completely figured out. What's the killer app? For me, the killer app is something I walk along, it recognizes people coming down, and it says, that's so-and-so. You saw them last on this date. You talked about this subject, yeah. and you were supposed to respond to their email last week. So that's kind of the ultimate kind of, that's a tool I'd really like. But I think some of the interesting things we'll get, I mean, if you imagine being able to, I occasionally will compose a short email just by voice on my phone, but not anything sophisticated. I'd like to be able to compose a sophisticated email. Respond to that email, so-and-so sent me, tell them this and this and the other thing, and check my calendar to make sure this date works. I'd like to do all that, right? And so you'd like to have this kind of model that knows that to check my calendar, it goes here, to do this, it does that. I think we can get there with these kinds of applications.
I heard a lot of clapping, so I think that it's a killer app.
Yeah,
for many of us.
Get the killer app.
Okay. Elias? Oh, okay, Eric.
You talked a lot about the future of technology and touched on regulations. One thing that we haven't touched on is geopolitics. And I think about, like 10 years ago, US venture capital was pouring into China. Sequoia had its global partner meeting in China. Chinese venture capital was pouring into the US. 5 years ago was like an interesting point where you had TikTok and Shein and a bunch of Chinese apps become globally popular. And all of the Chinese self-driving car and truck companies were founded around here. So Silicon Valley and LA and East Coast. And now we've really started to decouple. Is this a blip, or do you think this is part of a wave? Is the decoupling going to continue? What is your view of US versus China technology for the next 10 years or so?
Well, I think it's difficult to predict. I think the US and China have to sit down at the same table and have a discussion about the global order and how they're going to compete economically, but to do so on a fair basis and a basis where everybody agrees what the rules are, and then also have a discussion about other things like, are we going to allow development of AI and military weapons, for example, which would, I believe, would be horrendously terrible for the world, horrendously terrible for the world. So I think it's time that that discussion got started. You know, you cited 10 years ago. I mean, I've been going to China for a number of years, and I was very hopeful about the country and the direction it was going 20 years ago, even 10 years ago, but the last 10 years have been really difficult, and difficult for the United States, and difficult to think about how you have that kind of conversation and reach an agreement on how to move forward. But I think that's really necessary.
Maybe on the geopolitics, there's a lot of discussion about slowing down AI, pausing it, throttling it. It can't work when you have geopolitical aspects. So what do you think is the hope here?
Well, I don't think we're going to slow down or pause it, because nobody who's suggested pausing it or slowing it down says what they're going to do in the 6 months they slow it down. How are they going to solve all the problems of this technology where we don't even know what the technology may be able to do? I think the right way to think about this is, look, it's a technical tool. It can be used to do a lot of good in the world, right? And think of it like electricity. You can do a lot of good with electricity. Yeah, can people stick their hands in a socket and get electrocuted? Yes, they can. Yes, they can, right? The same is true about fire. The same is true about automobiles. The same is true about a lot of things. They can do bad as well as good, right? And this technology can do a lot of good. We as a society have to think about how we police the bad uses of technology and prevent those while trying to promote the good uses of technology.
Yep. Regulation and international alignment.
International alignment is going to be key on this.
Yeah. Okay, I'm looking for one question here.
Hi, this is Naoto from Hennessy, Japanese company, and thank you very much for that sessions. I'm quite interested in, you were talking about the biases. So we are all biased, and AI also, maybe the GPT could be biased. So maybe ChatGPT will recommend Bing as a better search engine, and Bard will recommend Google as a better search engine.
Well, one is truth, the other is hallucination. I couldn't help.
That is yeah. Very simple samples. And as you mentioned, maybe the AI will learn more and more. They will be more biased from where they learn from. And after that, I'm just afraid that AI could be more humanized. So where the AI is learning from. So for example,
so I think you need to think about what the end use of this technology is and how you deploy it. And think about if bias is a real concern. Are there inputs you don't even want, right? So you don't want to include race, for example, in the training data because you're worried about it then deriving things that would be biased on the basis of race or place of birth or gender, for that matter. I mean, in some cases you won't want. I mean, if I'm building a system, for example, to do auto-grading of students' assignments, I don't want to consider whether a man or a woman submitted that assignment. I want to grade it the same way, right? So it's up to us to really decide where those potential biases may come in and then ensure that the system isn't using that in its training or in its inference when it does inference.
Thank you.
Hi, I'm just here as my husband Bob is. Bring your wife to work day for him. So I wanted to ask you, what potential opportunities do you see at the convergence of AI technology and the financial industry? Because we had an account at the Silicon Valley Bank, and you know what happened with that. But how do you see AI playing a role in forecasting those kind of situations?
Yeah, I think clearly you can't forecast things that are wholly novel, but you can train on past history. And certainly somebody who had trained a model to look at risks of various sorts could have trained a model that included the risk that interest rates will get raised, right? Now, lots of smart people have messed up on interest rates, and they've made the wrong gamble on it. The thing is that to make that gamble without any insurance that you could fall back on was the mistake that occurred in this case. And if you trained on enough financial data, you would have trained on cases where there was this interest rate squeeze. And that would have told you that that's a very dangerous thing to do, to bet that, and you need to have a higher capital reserve. I'd say in this case, it's probably also the case that the regulators made a mistake. They removed some of the capital reserve elements. They lowered them for mid-sized banks. In retrospect, and I know they did it so that mid-sized banks would do more lending into the community and things, but just as we saw with the housing boom bust back in 2008, 9, 7, you can tweak some things in the financial industry that may have good objectives, but may have negative outcomes, and that's what they have to think about and train for.
Okay, one in the middle, Elias.
Thank you. Elena Lian from Intel Capital. Really appreciate that section. My question is, where do you see as the value accretion from a startup compared to a large company with a lot of data? For instance, Midjourney with 11 full-time employees get to their size. On the other token, from AI infrastructure company to Copilot, vertical application side. What's your view on where the value land?
Yeah, I mean, I think you look at history of Silicon Valley and what's happened over the last 40, 50 years, and startups have always played a key role in bringing new technologies which perhaps the established players were not willing to invest in and use initially, along and make those technologies incredibly successful. And you just look at history over history. Well, shouldn't Yahoo have figured out that there was a better way to do search and Google never should have been created? Shouldn't Google have figured out that social media was going to take off and Facebook never been created? But that's not the way the Valley works. The Valley kind of is this constant retry of stuff. And the other thing I'd observe about it is, if you look at there's basically big wave effect that occurs periodically when some new technology, mobility came along, right? And the idea you could get mobility. You know, when we started Atheros, half the VCs turned us down. They said, "Oh, you're technically too ambitious. It's not time yet. Come back in 5 years." So that happens periodically, and what the entrepreneurs do, in my impression, particularly entrepreneurs are taking a new technology out, not just building a niche product, but it's a new. They see the glass as half full. Everybody else sees it as half empty. And that's the difference. And the entrepreneurs are going to work as hard as they can to try to fill the rest of that glass. And that's what's going to make the difference. And I think the one thing you learn having been in Silicon Valley is don't ever get comfortable. Because when you get comfortable, the new startup is going to come along and eat your lunch.
John, I had one more question, but I have to finish with this. This was too good. Thank you, John. It was amazing.
Thank you. Thank you all.